Hello, ladies and gentlemen. We're going to continue evaluating trig functions. We're going to keep running with what we were talking about before, but let me kind of remind you where this is coming from. I'm just going to draw a triangle. I'll do it in the first quadrant. It doesn't really matter. But if you're talking about an angle, and I'll say theta here, and we'll say we're on the unit circle, so that's 1. If I say what is the cosine of theta, the cosine of theta would be whatever this x-coordinate is, because that's adjacent, divided by 1. So when we say cosine, what we're really talking about is the x-coordinate of the terminal point. Similarly, when we say sine, we're really talking about the y-coordinate of the terminal point, because if you go opposite over hypotenuse, you get the y-coordinate. And the last one that you need to make sure you understand, tangent is the ratio between these two. So this is y over x. Now that we know those things, we can start to piece together where each trig function will be positive and where each trig function will be negative. This is the same as what we're doing with just x and y in terms of in the first quadrant, x is positive, y is positive. In the second quadrant, x is negative, y is positive. In the third quadrant, everybody's negative. And in the fourth quadrant, x is positive and y is negative. So this is all I'm really asking you to do up here, as long as you understand that every time I talk about cosine, I'm talking about x. So these are the answers for cosine. Every time I ask you about sine, I'm asking you about these guys, the y-coordinates. So when I say is cosine positive or negative in the first quadrant, x is positive. In the second quadrant, x is negative. In the third quadrant, x is negative. And in the fourth quadrant, x is positive. Let's do the same thing with y's. In the first quadrant, y is positive. In the second quadrant, y is still positive. Third and fourth quadrant, y is negative. You're below the x-axis. So when you're below the x-axis, y is negative. Tangent is the ratio between them. So you can think about it in terms of, oh, I know what this one is, but you have them right here. So we're just going to divide these two things. It's sine over cosine. Doesn't really matter when you're dividing, but plus divided by plus would be plus. Plus divided by minus would be minus. Minus divided by minus is plus, and plus divided by minus, or the other way around, is minus. So we can find the sine of each of these trig functions just by thinking about the x's and the y's. Now, they're not up here, but you should consider that cosine and secant are going to have the same sign because they're reciprocals. Reciprocal doesn't change whether it's positive or negative. Similarly, sine and cosecant are going to have the same sign, and tangent and cotangent are going to have the same sign. So if you say cosine's positive, secant's positive. Same thing. Now what we're going to do is use this idea to kind of multiply some trig functions and just tell me, is it going to be positive or negative? So let's go through the same thing. In the first quadrant, if you're talking about quadrant 1, x and y are both positive. So if I said, is sine positive or cosine positive, just be like, okay, look, sine is positive in the first quadrant and cosine is positive in the first quadrant. So sine times cosine, a positive times a positive would be positive. So I'll just kind of, if you want to see it, it'd be plus times plus equals plus. Let's do quadrant 2. Quadrant 2 is over here. In the second quadrant, cosine is negative and sine is positive. So we would say the sine is positive and the cosine is negative, and a positive times a negative would give you a negative. Quadrant 3, down here. They're both negative. In quadrant 3, you could say sine is negative and cosine is negative, and a negative times a negative would give you a positive. Last one, quadrant 4. In quadrant 4, x is positive, y is negative. So if I say what's the sine in quadrant 4, the sine will always be a negative number. The cosine in quadrant 4 will always be a positive number, and their product, a negative times positive, would give you a negative. So we can do this as many times as we want, but I'm going to do a couple more here. Remember that tangent is positive when x and y are the same. So the way you can get a positive tangent is if x and y are either both positive or both negative, because when you divide a positive by a positive, you get a positive. Same with negative divided by negative. So let's do first quadrant. In the first quadrant, everybody's happy. Tangent's happy, positive. Secant's happy, positive. Their product would be positive. In the second quadrant, tangent is negative, and tangent is negative because they're opposite signs. And in the second quadrant, cosine is negative. Cosine, remember, is the reciprocal of x. And if x is negative, then the reciprocal of x will still be negative. So a negative times a negative will be a positive. Quadrant 3. In quadrant 3, tangent is positive because the ratio between them is positive. And secant is negative because secant is the reciprocal of cosine. Plus times minus will give you a minus. Quadrant 4, x is positive, y is negative. So if I do the ratio between them, y over x, negative divided by positive, I'll get a negative. And secant is the same as cosine as far as its sign goes. If cosine is positive, then secant is positive. So negative times a positive is a negative. Let's do one more of these. Cotangent is going to follow the same sign as tangent. So in the first and third quadrants, I'm going to write all of them out here. In the first quadrant, cotangent is positive. And in the, I'll just do them all at the same time. Maybe that'll be easier. We'll try it. Okay. So in the first quadrant, cotangent is positive. In the second quadrant, cotangent is negative. In the third quadrant, cotangent is positive. And in the fourth quadrant, cotangent is negative. Once again, that's because when x and y are the same, you'll get a positive. So this is x over y. Those are positive, and these would be negative. In the first quadrant, sine is positive. In the second quadrant, sine is still positive. In the third quadrant, sine is negative. And in the fourth quadrant, sine is negative. Now we'll do cosine. In the first quadrant, cosine is positive. In the second quadrant, cosine is negative. In the third quadrant, cosine is negative. And in the fourth quadrant, cosine is positive. So what would these come out to? Positive by a positive by a positive is positive. These would cancel out, so you'd have a bunch of positives again, and you get a positive. These would cancel out, and you get positive. And look at this. These cancel out, and you get positive. So no matter what angle you pick, this will always be positive, as long as cosine of the angle isn't 0, because then you can divide by 0. But as long as you pick an angle that you can actually evaluate, this will always be positive. This fraction will always come out to be positive. And later on, we'll talk about trig identities. So I'll just show you because it's kind of fun. I like doing it. Cotangent is cosine over sine. Sine is sine over 1. And then this is cosine over 1. If you actually simplify this, you end up with cosine of t over cosine of t, which turns out it's not that it's always positive, it's that this is always going to be 1. So it's kind of fun. I can tell you that they're all equal. Just 1. Okay. Now, we're going to do this same idea here, but we're actually going to be given some numbers. So this is going to be a little bit fancier, and you got to be real careful here. So the first thing I'm telling you, and if I ever tell you information about the angle in terms of what quadrant it's in, you have to understand that's very important information. So these are in radians. If I was in degrees, I would say this is between 90 and 180 degrees. And we'll talk about radians more next week. But what this is saying is the angle that we're working with is between 90 and 180 degrees. That means it's in the second quadrant. So we're in the second quadrant. And it says sine is positive, which sine is the y, so it should be positive. So I'm going to call this theta, and that's my reference angle. I'm going to use theta. When we say t, we're really talking about this, but theta is what I'm going to always reference, so we say that's the reference angle. The sine of that angle is 4/5, so 4 over 5. Now notice, we are not on the unit circle. Just keep that in mind. Now this is a Pythagorean triple. If the hypotenuse is 5 and one of the legs is 3, then the other leg will always be 3. 3 squared plus 4 squared equals 5 squared. So that means I'm just going to label this 3. But going back to what I was saying before, if you're in the second quadrant, you have to remember that that's negative because we're to the left of the y-axis. So x is negative in the second quadrant. I'm going to label it on the triangle just so we understand that we're in the second quadrant. Now we're going to actually evaluate this with numbers. So if I say what's cosine, cosine is adjacent over hypotenuse, so negative 3 over 5. Sine was given to us, it's 4 over 5. And tangent is opposite over adjacent, so we're saying minus 4 over negative 3, which is, when you subtract a negative, you're going to just say that's the same as plus. Now when you multiply fractions, you multiply across. 3 times 4 is 12, it's negative. 5 times 5 is 25, plus 4 over 3, which we need to get a common denominator. The common denominator between 25 and 3 is 75. So we'll triple this guy, and we'll multiply this guy by 25. And now we have negative 36 plus 100 over 25 times 3 is 75. If you do 100 minus 36, you get 64 over 75. So if I am given that information, what I can confidently say is that this will come out to be 64 divided by 75. Let's do another one. Secant plus sine times cotangent. So secant is the reciprocal of cosine. If cosine is negative 3 over 5, then secant would be negative 5 over 3. It doesn't matter if you put the sign in the plus or the top or the bottom. I always put it at the top. So secant is negative 5 over 3, or hypotenuse over adjacent, plus sine, given to us, 4/5 times. Cotangent is the reciprocal of tangent. So instead of opposite over adjacent, instead of 4 over negative 3, we're going to say negative 3 over 4. So that's negative 3 over 4. Another way of thinking about that is adjacent over opposite. We're going to do the same thing. Negative 5/3 minus 12 over 20. I'm going to need to get a common denominator. So the common denominator between 3 and 20, let's see. This is 4 times 5, so I think it's just going to be 60. Times 20 times 20. That was weird. Times 3 times 3. So 20 times 5 is 100. That's negative. And 3 times 12 is 36 over 20 times 3 is 60. So this is negative 136 over 60, which will reduce. We can reduce that a little bit, right? Let's see. 136 is even. If you cut it in half, what do you get? 68. 68 over 30, which is also even again. So I'll do negative 34 over 15, and I think then I'm good. So negative 68 divided by 30 is negative 34 over 15, and then that's my answer. All right, let's do some other problems just like this. Tangent is 1. Well, that's weird. Okay. All right, first thing. This is tricky. Tangent is positive 1. So you have to remember, tangent is only positive in the first quadrant and the third quadrant, because it's either plus plus or minus minus. The second thing they're telling us is that sine is less than 0. So sine is negative. Remember, sine is the y value. So to meet both of these criteria, tangent has to be positive in one of these two, but sine also has to be negative. Sine is positive in the first quadrant, so that means what we're saying is we're in quadrant 3. Just figuring that out is going to be really important. We're in quadrant 3. Now, it says tangent is 1. So how do you make tangent 1? When would opposite over adjacent be 1? When the sides are, or when the sides are the same in an isosceles triangle? So you could probably just go 1, 1, and then do Pythagorean theorem. 1 squared plus 1 squared is 2, and then we'll call this radical 2. Or you could use your values from the unit circle, radical 2 over 2 if you want. I'm going to do it this way, and we'll just see if how it goes. So cosine, actually, you know what? I'm going to have to rationalize it anyway. So let's use the unit circle values. Radical 2 over 2, radical 2 over 2, and we'll say we're on the unit circle now. So tangent is 1 because opposite over adjacent, when you divide it, you get 1. So cosine is negative radical 2 over 2. Secant, negative 2 over radical 2. Wait a minute. Cosine times secant, those are reciprocals. They all cancel out and you just get 1. So this is 1 minus. Cotangent is the reciprocal of tangent. Well, if tangent's 1, then guess what? Cotangent's 1. So this is saying 1 minus 1 equals 0. Whatever angle you pick here where tangent is 1, you will get 0 if you evaluate this out. Okay, that's kind of cool. Now let's do one more. Cosecant. So cosecant is the reciprocal of sine. Well, it doesn't really matter. It's the same as cosine. So we're going to say cosecant is negative 2 over radical 2 divided by tangent, which is 1. So nice. Plus cosine, which is also negative radical 2 over 2. I'm going to have to rationalize this to make a common denominator. So negative 2 radical 2 minus radical 2 over, this is 2, and that's 2. So I have a common denominator of 2. You have negative 2 radical 2's, and you take away one more radical 2, you have negative 3 radical 2's. Still over 2. So that's your answer. There. Okay. So I rationalized the denominator by giving him a buddy, and then I knew that my denominator here was 2, so I could just focus on the numerator. Negative 2 radical 2 minus radical 2, which those are like terms. You're basically just doing negative 2 minus 1, which is negative 3, but you're saying, how many radical 2's do I have? You have negative 2 of them, you subtract one more, now you have negative 3. One more, sine is 3/5, and you're in quadrant 2. Okay, quadrant 2, gotcha. I feel like we did one like this earlier. Sine is opposite over hypotenuse. This is the Pythagorean Triple. That's got to be 4, and it's negative in the second quadrant. X is always negative in the second quadrant. So let's find everything. Well, I got sine. That means cosecant is the reciprocal, 5/3. Nice. Cosine would be adjacent over hypotenuse, negative 4/5. Secant would be hypotenuse over adjacent, negative 5/4, or you can just put this. Tangent would be opposite over adjacent, negative 3/4, and cotangent would be negative 4/3. So that's it for evaluating trig functions. Really, the only piece that we're missing now is to connect the unit circle with the evaluating the trig functions, which we're not going to do right now, but that's where we're going next. So what you need to make sure you can do is, number one, tell me where all the terminal points are on the unit circle. That's one component. And now this part of it is you need to know where x and y are positive, which tells you where cosine and sine are positive, to then be able to do some of this other stuff, which when we start to combine these two ideas together, obviously it's really important that you're good at each of them. So you have a couple checkpoints to do, you have a couple math labs to do, make sure you get all of that finished, and also hit that like and subscribe button.